Okay, so here's our unwrapped um, robot, and he's my gas bot. I don't have him rigged or anything yet or textured, but I want to take a break and I want to do some programming of my game. For me, it just makes it a little bit easier to jump around. So I made a new Unity project. Pretty simple. You just go to File, you run Unity, make a new project. I named mine Periodic Planet. I imported in the robot. The way I do it is I go to File, Export All, and I export it as an FBX, and then I just imported it in here. And I created a folder structure where models, characters, enemies, robots, gas bot, and then I just have this gas FBX. So the way you import is you just right click, import new asset. I have a bunch of tutorials on the interface of Unity. I just kind of want to get into making a game. So look online, find some other stuff also to help you out if you need it. Um, it's kind of more of a mid-level tutorial. So I'm going to make another folder here, and I'm going to call it prefabs. And in that prefabs folder, I'm going to make one called robots. And I'm just going to grab my gas bot and drop them in here. Now the difference between a prefab and the initial model is a prefab can hold multiple different components. So an example of this is we're going to create some enemy AI, and we're going to do that in a C# script, and we're going to add that component to this prefab. So watch how I grabbed it. Now I'm not in my hierarchy, I'm actually my project. If I just drag and drop this on here, if I go jump up here, you'll notice it added it there. So there's a connection between the prefab. Right, I'm going to double click this script and fire up Visual Studio. There we go. We're going to create a couple variables. So a, uh, we're going to store the target, which is going to be our player. Store the target of our player. And we're going to be using that position to calculate things like where our enemy is going to look, and that's what we're going to work on first. So we're going to create a flag. So first things first is public transform, and then target. Let's save that. And I just added a sphere in my scene. And let's go here. Oops, not my sphere. So this sphere is just going to represent my player until we model one. Now notice when I save that, the script that we just added, it made a public variable called target. And I can just grab my sphere and drop it in there. Now what we need to do is we have that. We also need to check, we need a flag to check if our character is in view. So I'll do boolean is in view. And then we are going to create a cycle or set time for resetting when our enemies look at the player. So it's going to run through a random cycle. And that's that. And then we need a counter. And this counter is going to be a time. Let's do 10 for this, or 15. So what's going to happen is our counter starts at 0. And it's going to count up, and we're going to check if it's less than 15 seconds and then reset it later. All right. Let's see. In our update function, we're going to, let's create a new function called field of view. This is going to be where we do all of our calculations to check the field of view. And I'm just going to call this function in here. And it's going to be called every frame. All right, so inside of field of view, we're going to check if we found our target. I'm going to make this lowercase. And we also want another check inside of here That is just checking if our character is in view. So is in view. Now the first thing we need is we need to grab the distance between our position and our transform's position. So that's like whatever our target is and then our current position, and we want to subtract those two numbers to give us a midway point. That midway point is going to be the distance in which our robot can see. Okay, so we need to know, so variable that can detect how far our enemy can see. So we're going to do that as a vector3. And we need it to be a vector3 because we're going to be, imagine a cone of vision coming out of our, actually we'll do a float, just a single value, and then we'll use that in a vector3 later. So float distance, and that equals a vector3 dot distance. And what's nice about this is this will give, the distance is calculated by the target's position, and then we can do our current, this is our robot's position. Okay, so that's what we're checking. So our distance right now is, we're checking our beginning, our starting point, and then our ending point. So let's go ahead and use that. So is in view is a Boolean. It's going to check true or false. What's interesting is you can actually say, if the, sort of like an in, as a if statement, you can say is in view, right, equals, which means it's only true if distance is less than 200. So this is checking if we see the target at a range of 200. All right, so let's save that. So looks pretty good. All right, so let's make a vector3 in here, another variable called direction, vector3 direction equals target dot position minus the transform dot position. Okay, so what this is the direct, so this is the distance, how far we can see. Now our direction is going to be calculated by, we're going to grab our target's position, our transform position, we're going to subtract it, and that's going to be where we're looking at. Okay, so we need to grab, here, let's, if we see our player, grab the direction between enemy and player, and what we'll do is, let's see, we'll make sure our direction's y-axis is set to 0 because we don't want him looking up. We also don't want this running every frame because of time constraints. So what I'm going to say is if our counter, which is currently set to 15, is less than cycle, or I'm sorry, our counter is set to 0, is less than cycle, what we can do is we can call field of view, and then we want to increment counter. So, and then we might actually increment it outside of this if statement. Yeah, let's drag counter. Let's drop it up here. So the first thing it does is it updates my counter and then it checks this. Another thing that might be interesting is if we grab this if is in view function, or I'm sorry, this if statement that we just created, it might be a good idea to, let's just put this inside of our update for now, because we're going to be getting the rotation and it'll actually run a little bit smoother. It'll be less jagged if we're constantly checking field of view opposed to running smoothly in real time. So let's go ahead and expand this a little bit. So if we are in view, we'll set our Y. we'll grab our direction, and then what we'll do is we'll check if our direction is the same as 0. We'll set our directions dot transform position. I'm sorry, direction equals transform dot position. Okay, so what's happening here? So oh, I'm sorry, vector3.0. So what's happening here is if we don't see anything, right, we're at 0 here. Our direction equals 0. Because remember, direction is based on our target position and our transform position. So if we don't see anything, we'll do transform dot forward. Look forward. Now what we'll do for our counter too is we'll make it sort of, we'll add more interest here. We're making it equal to random dot range. And we'll set that range to 0 and 15. So what that's doing is every time our program starts once, and remember we're going to have a bunch of enemies in our scene, we'll set our counter to, you know, between 0 and 15 so that it gives us a different cycle to call field of view. That means they'll check at different times. It'll add a little bit of randomness to our enemies. All right, let's see what else is going on in our code here. We need to finish up our is in view function here. Okay, so we have transform.forward if our direction is not equal to 0. We need to grab the angle. So let me pause the video because we're at 11 minutes and just code up the angle and then I'll explain it. All right, so this is this little bit of code that we have here is used to detect if our enemy is in front of it. So this kind of fills out the code, but we're storing the angle of our current transform. So this is from where we're starting, the center of the robot, to the direction that we calculated earlier. If our angle is greater than 45 degrees, that means that it's, let's see if I can sketch this out for you in Photoshop. I'll do it in a second, but essentially you have the enemy who's standing in front, and then you have a cone of a 45-degree angle. If you walk into that cone, if we check that, what we'll do is we're going to set our target's rotation is equal to the look rotation of the direction we're doing. And then we're going to take our target rotation and we're going to actually rotate our model with this. So our transform rotation equals, and slurp is a nice smooth way of interpolating between 2 points. And the 2 points that we're going to be interpolating or rotating, that's what a quaternion is the rotation of our current object to the target's rotation, which is what we got here, and then the speed in which we're going to do it is here. So I'm going to save this. Let me just scroll up, and then I'm going to slowly scroll down. Feel free to pause it as I go to kind of make sure that your code looks similar to this. And go back in and rewrite this code by hand or correct it or whatever. All right, and let's test this out. So I'm going to jump back into Unity here. Now notice that if you see that yours isn't working, make sure your z-axis is pointing forward because that's the 45-degree angle we're looking for. And then make sure that in this target slot, which is the variable that we have here, right? This is a public transform, so it shows up here, target. You grab your sphere and you drop it in there. It's going to represent, for now, this sphere just sort of represents our player until we model that. So I'm going to select this. Now notice how it's slightly rotated, and that's because it's looking at the sphere. And remember we set the direction to 0, it will not look up. Now watch this. If I go behind it, I can actually sneak up on this robot because it's not within that 45-degree angle. But as long as we're in front of it, it'll look at it. Alright, so that's it for this one. We'll go back to maybe ZBrushing our robot in the next video.